профессор Мария Луиза Лопес Фернандес и доктор философии Саладат Лопес, университет Наварра, Испания. Хотела бы вас всех попросить поставить микрофон на мьют, пожалуйста.
Я не слушаю.
Good day, dear participants, speakers of the International Summer School 2020.
No sé lo que tengo que hacer.
Before we start, we would like to welcome again all our...
Не слушаю.
Just a moment.
Не слушаю.
Hello, can you hear me?
Yes, I can hear.
Yes.
Can you hear me?
Yes, I can continue. Здесь какой-то шум, но если вы меня слышите, я хотела бы продолжить. Okay, good day, dear participants, speakers of the International Summer School 2020. Before we start, once again, I would like to welcome our new participants. We are glad to start our fifth day session of our online summer school. Today's lecture will be given by the professor Maria Luisa Lopez Fernandez and Soledad Lopez, PhD, from Navarra University, Spain. So before we start, I would like to ask all the participants, as well as the speakers, to put microphone on mute, please. So please, the floor is yours, Professor Maria Luisa Lopez and Soledad Lopez.
¿Cuándo puedo quitar?
Estás en silencio.
No vas a ver. Espera. ¿Qué quieres? ¿Qué haces?
Estás en silencio.
Espera un momento, por favor. Estás aquí. ¿Estoy en silencio?
No.
Es que estoy aquí. Hello? Can you listen to me?
Yes, of course.
Could I begin?
Hello?
Yes?
We are ready.
Yeah. So,
Right. In Spain, it is already morning. Good morning or good afternoon, every participant. It's with great pleasure that I'm going to talk to you of my most interesting theme, the bioclimatology. And климат как фактор усиления ограничения кондиционирования зеленой экологии. If we are to work with the green ecology, it is very important to know very well the climate. So I begin. Let me see. The main author that has create the bioclimatology, this science, is Professor Rivas Martinez. We are going to follow his ideas expressed in this publication, this paper, a worldwide bioclimatic classification system by Rivas Martinez, Salvador Penas Angel, Global Geotony Volume 1, December 2011. It's a big publication, 664 pages and 4 maps. Bioclimatology is an ecological science that studies the relationship between the climate and the distribution of the living beings and their communities on Earth. It's important to have a bioclimatic typology for the whole Earth, an unified bioclimatic typology with an adjusted correlation between quantitative climate values. Martinez has these units: macrobioclimates, bioclimates, thermotypes, ombrotypes, isobioclimates. We are going to have to see all of them in this talk. It's important to have an accurate relationship between vegetational models and climatic values so that it can be used in predictions for obtaining agricultural and forestry resources, in the fight against hunger, in investigations into climate change, and in determining the future climatic and vegetational scenarios on Earth. Rivas Martinez and his school have made this science because the knowledge on the distribution of vegetation on Earth is increasingly detailed, and it is possible to recognize bioclimatic and plant frontiers with greater precision and objectivity. And so it is possible to statistically calculate the threshold numerical values that define them. As a result, the spaces corresponding to the bioclimatic units, macrobioclimates, bioclimates, thermotypes, and ombrotypes, have been progressively being defined. This school, this bioclimatic school, is a new bioclimatic classifications. There have been several, but only a small number of bioclimatic classifications have been proposed and used to date with a global ecological intention. You may know Köppen, Tom White, Emberger, Gossen, Walter, Troll and Puffen, Holrichs and Box. Despite the suitability of many of them, in some cases their widespread acceptance, Rivas Martinez and his school considers that in some important aspects there has not been a response to certain situations that occur on Earth. And I'm going to speak about the significant differences between these previous classifications and the one from Rivas Martinez. For instance, the old classifications include all the high mountains on the Earth in a single climatic category, or bioclimatic zone, oroclimates and orobiomas. However, Rivas Martinez considers that mountains represent altitudinal thermic variations, which in many cases can be expressed through the altitudinal zonation CLINOS sequences of the bioclimatic stages, and typical vegetation of the macrobioclimatics found in valleys and their adjacent plain. The reason is because mountains of different parts of the world at different latitudes have differences in the duration of the day and night throughout the year. So our author, Rivas Martinez and his schools, considers it is not possible to constitute the mountains as a single bioclimatic unit in the Earth. This is a very important point. The second point is about deserts. Previous classifications have included all deserts in one bioclimatic, but Rivas Martinez school thinks that the annual oscillations and the seasonal rhythms of rainfall and temperatures that go with latitude from the equator to the poles made it impossible to put all the deserts in one section. Apart from the frozen, hyperfrozen cryodeserts, these authors think that there are two types of deserts in the tropical macrobioclimatic and four types of deserts in the Mediterranean macrobioclimatic. And the third very important difference is about the Mediterranean macrobioclimatic. Most of Central Asia has a Mediterranean macrobioclimatic, and that is very important, this interpretation. This bioclimatic Mediterranean has dry summers with at least 2 consecutive summer months, the long days, with precipitation, with the monthly precipitations less than twice the median month temperature. The plants, the flora of these spaces with this aridity during the summer is very high. It's highly original, rich and diverse flora. We can summarize all these reasonings, previous reasonings, in some axioms or principles. The worldwide classification, bioclimatic classifications of the world must have the same, these conditions. Reciprocity. In bioclimatology, there must be a close and reciprocal relationship between the climate, the vegetation, and the geographic territories. Photoperiod. The different length of day and night throughout the year due to latitude represent a severe frontier for many plant species and communities. Continentality. This is the range of amplitude between the average temperatures of the most extreme months of the year, a value expressed in degrees centigrade, which corresponds to the simple continentality index, has an extremely important influence on the distribution of vegetation and, of course, on the frontiers between many bioclimates. Another axiom, very important, the annual rhythm of precipitation throughout the year is equally or indeed more important in terms of composition and distribution of plant communities than their quantity. We have already talked about Mediterraneity, and the authors, Rivas and the others, consider that there is an extensive Mediterranean macrobioclimate at any altitude and continentality value, latitudinally extratropical, umbrically opposed to the tropical and to the temperate macrobioclimates, with a summer drought lasting at least 2 consecutive months, with the precipitation, 2 months with precipitation less than twice the temperature. This lack of rainfall during the summer, maybe even extend to cover all the 12 months of the year in the desertic and hyperdesertic Mediterranean bioclimates. Deserts we have already talked about. There are several types of desertic bioclimatics in the tropical and in the Mediterranean bioclimates, depending on the latitude and their amount of precipitation. Oroclimates. The bioclimate of mountains, except in the temperature and precipitation, has a close relationship with that of their foothills. So there are this zonation, step by step, altitudinal vegetation stages. It can be expressed by temperature and humidity, and it is not needed a special bioclimate for the mountains. The peculiarities of the mountains can be expressed in vegetation stages, in stages of thermicity and of humidity. The orogens. In Central Asia, there are some places where the plants couldn't move from north to south according to the changing of the climate. And it must be taken into account in the classification of these stations. And as we shall see in 3 or 4 slides later, the bioclimatic typology of these authors, or bioclimatics units, are macrobioclimates, bioclimates, thermotypes, umbrotypes, isobioclimates. These words may seem very strange, but let us see. The macrobioclimates is the supreme typological unit of the Rivas-Martinez classification system. They are defined by specific climatic and vegetational values, and macrobiocclimates cover a wide range of territory. The authors consider 5 macrobioclimates: tropical, Mediterranean, temperate, boreal, and polar. These big units can be divided in smaller ones called bioclimatics. Rivas-Martinez recognized 24 bioclimates for the whole 5 continents. And these 5 macrobioclimates and these 28 bioclimates are represented by a series of plant formation, biothenosis, and typical plant communities. There have been recognized also a number of variations in the thermic or umbrothermic values, and they constitute these units, thermotypes and umbrotypes. And if you put all these units together, we go to the isobioclimates, which is a model formed by a bioclimate, a thermotype, and an umbrotype. Each isobioclimate is the unit, the very, very important unit. Each isobioclimate has its own bioclimatic space, which can be identified by the thresholds values of each bioclimatic units of which it is comprised. How many of these units do we find in the Earth? More or less 400 isobioclimates are recognizable in the geosphere, but only some 300 have an appreciated territorial space. These isobioclimates are useful for identifying similar territories and equivalent types of vegetation, and for creating highly precise bioclimatic maps, as we shall see in the next slides. This method, worldwide bioclimatic system, has already been applied in North America. The numbers refer to the bibliography, which is here, and we shall see here. In North America, in Mexico, Central America, Dominican Republic, South America, Venezuela, Bolivia, Chile, Peninsular Spain, Portugal, Italy, Asia Far East, Russia, Kazakhstan, Iran, Palestine, Africa, Oceania, Australia. And here you can see these numbers, the publications where this method, the worldwide bioclimatic system, has been used. From 5 to 10, 12 to 16. And by the way, here are some of our publications about the Far East Russia. This one about Kazakhstan. This also about Kazakhstan. And this one about, here am I, Australia. Some authors have expressed their opinion about the method. For instance, Torregrosa and others from San Francisco, California, in this publication, Present, Future and Novel Bioclimates of the San Francisco, Californian region, say to explain the climate space of either individually considered plant species or plant communities, the landmark study of biological relevant categories breaks of climatic variables by Rivas Martinez generated a hierarchical classification, the Rivas Martinez Worldwide Classification System, that provides numerical-based methods. We use the Rivas Martinez Worldwide Classification System for our study area because it scales hierarchically and captures with high sensitivity the precipitation and temperature patterns that differentiate plant communities. Also, in Iran, Jamali, Alkami, and others, applications of the Global Bioclimatic Classification to Iran, etc., in Ecologia Mediterránea 2011, the authors conclude that bioclimatic zones identified using the Rivas-Martinez system correlate well with the main phytogeographic regions of Iran at the macrobioclimatic level and with the main biomas of the biomas at the bioclimatic level. An advantage of this classification over other bioclimatic classification systems is the inclusion of both seasonal and annual variations in those climatic parameters that are significant for the growth and development of plant population and community. They also comment this system has successfully been applied to different parts of the world and seems to provide good matches between bioma and climate boundaries. So, what do we need to use this classification? We need climatic data. They may be historical from the past, the present, what is happening in the climate now, and also we can use projections. Rivas-Martinez has used very simple climatic data so that many climatic stations from all over the world could be used. No sophisticated stations, no, very, very normal. We need only monthly average of precipitations and monthly average of maximum temperatures and monthly average of minimum temperatures. So very simple climatic data, but very good selected climatic data, especially the periods, the data, the months we take for each index. A careful selection in the choice of data corresponding to the sensitive periods of the plants and vegetation for the use of climatic data: monthly, bimester, trimester, 4-mester, 6-mester, years. We shall see these periods when we analyze the parameters and bioclimatic indices used in this classification. So here we have a station, Yescasgan. We need its altitude, latitude, longitude, period for observations for temperature, 27 years, rainfall, observation period, 11 years, usually 1968 to 1994, 1984 to 1994. And what do we need? Monthly median temperatures, monthly median temperatures of the maximum, monthly median temperatures of the minimum, and we can omit that, and monthly precipitation. Here you have the values for the year. With this data, the bioclimatic indices are calculated and the diagnosis here, for instance, this station from Kazakhstan, Yescasgan, has a Mediterranean desertic continental bioclimate. It's a supra-Mediterranean in temperature and arid. And here you have the Umbro-climogram. This is the temperature. Continentality index is very high, 39 from winter to summer months. And here you see the precipitation. So, how Rivas-Martinez and his school has chosen the data? Los parameters, temperature parameters, average annual temperature in degrees centigrades, Ti, average monthly temperature for each month of the year, average temperature of the maximum of the coldest month. This M is very important. Big M and small m. M, the average temperature of the minimum of the coldest month of the year. And then also very important, T max and T min. The max is average temperature, normal average temperature of the hottest month of the year. The min is the average temperature of the coldest month of the year. And then this is rather new. I think this is an invention from Rivas Martinez. PP, positive annual temperature. It's the sum, the total, intense of intense. Minute. Total intense of degrees centigrade of the average monthly temperatures higher than null. So temperature positive sums up the monthly temperatures of those months that are higher than null. Rivas Martinez thinks that when the temperature is less than null, the monthly temperature is less than null, the plants are frozen, survive, but they don't grow, they don't flower. But when the monthly temperature is higher than null, then the biochemistry of the plant initiates to work. So they enjoy those temperatures. And it is reflected in this very important positive annual temperature. About precipitation, the annual precipitation in millimeters, the monthly precipitation, as you see here, there are some parameters about 4 months. You see here 4 months. For the summer quarter, for the winter quarter, but very, very important, the positive precipitation. It is the summing up the precipitations of those months with median monthly temperature higher than null. So this is correlated, this positive precipitation is correlated with the positive annual temperature. Rivas Martinez sums up the temperatures of those months where the monthly temperature is higher than null, and sums up the precipitations of those months that have temperature higher than null. And then the bioclimatic indexes. In this classification, the continentality, oceanity index is very important. Is the difference between the median temperature of the coldest month and of the hottest month. Also, the thermicity index. This thermicity index is important because it takes into account the median annual temperature and the median of the minimal temperature and median of the maximal temperatures of the coldest month of the year. So this compensated thermicity index takes into account how cold it is in the coldest month. And now this EO, annual endothermic index. This is very important because it is the relationship between the positive temperature and the positive precipitations, divided by the positive temperature. This index has a correlation with the vegetation distribution, astonishing, really astonishing. And there are, this EOS2 is Ombrothermic Index of the warmest 2 months of the period of the summer. This EOS is very much related, if it is very low, with the Mediterranean macrobioclimatic. And now it is a great pleasure to show you the bioclimatic synopsis of the Earth. It is in one sheet of paper. Here we have the macrobioclimates, tropical, Mediterranean, temperate, boreal, polar, with its conditions, definition, which indexes are used, etc. Here we have the bioclimates, 5 in the tropical, 8 in the Mediterranean bioclimates, 4 bioclimates in the temperate macrobioclimates, 6 in the boreal, and 5 in the polar. Why this tropical macrobioclimate should be divided in 5 tropical bioclimates? Depending on the index ombrothermic, especially, you see? Especially. The Mediterranean macrobioclimate is divided in 8 Mediterranean bioclimates according to in ombrothermic index. It is explained 2 slides before, and the continentality index. And so the temperate also uses the EO and the continentality. The same for boreal, and then the polar takes into account the ombrothermic index, the continentality index, and also the positive temperature. So we have 5 macrobioclimates. We have here 28 bioclimates, and then the stages, the bioclimatic stages or belts. There are 2 aspects, thermotypes and ombrotypes. Thermotypes are related with temperature, and we take into account the positive temperature or the thermicity index. And here are the intervals, the thresholds of each stage thermotype. With respect to the ombrotypes, we use the ombrothermic index. You have here the thresholds and the names of the ombrotypes. So, with use of this bioclimatic synopsis of the Earth, you can classify any station, the data, the climatic data of any station, if you have the values for the medium values for each month. And now let us see some results. First of all, the bioclimatic classification of some meteorological stations. We begin with the tropical. Here we have a tropical pluvial from China, Wuchou, China. It's a tropical pluvial, mesotropical subhúmedo. As you see, the rains occur especially in summer, and the temperature are rather high, you see. Here we have Zapopan, Mexico. It's a tropical, pluvial, thermotropical, and subhumid. Here you have the temperatures rather high and the precipitation very low in winter, very low in autumn, and very high in summer. The precipitations may be less, then you have a very dry period, but the precipitations, the tropical xeric, occur also in summer. Tropical desertic from Karachi, Pakistan, almost, you see, very dry period. The temperature high, the precipitations very low. And the next one is a tropical hyperdesertic in Namibia. You see, there is almost no rain, and the temperature is relatively high, so mesotropical. What about Mediterranean? I have taken this from Tajikistan. You see, in summer we have a dry period. No, nevertheless, it rains a lot in spring and in autumn. Pluvioseasonal continental. The temperatures changes a lot between winter and summer. This one from Armenia, Yerevan, is a xeric. As you see, the rains here are less than here. The dryness period is in summer. Mediterranean desertic, Yescasgan. Continental, very extreme difference from winter and summer. Very low amount of rains and a dry period in the summer. Another Mediterranean desertic from Uzbekistan, very similar to the other one. This is colder and this is hotter. You see, in winter, the temperatures don't go so low. In Yescasgan, in winter, the temperatures go very low. Next, we have an hyperdesertic in Iran. So here are the temperatures. It's also a continental, great difference between winter and summer. And the precipitations are very low and occur in winter, in autumn, but not in the summer. So we have seen different stations with different bioclimates, Mediterranean. Now let us see temperate. This is an hyperoceanic in Ireland. You see the temperatures are very similar during all the year. The precipitations are very high. Temperate oceanic in Croatia. Here are the temperatures, the rains, very high. Temperate continental in Hungary. Always the rains up the temperatures. Temperate xeric in Ukraine. Very great difference between winter and summer temperatures. The rain. This is temperate xeric in Ukraine. Let us see the boreal. The temperatures are rather low, not under zero, but rather low. The energy, the thermic energy that receive these bioclimates, boreal bioclimates, is low. This is from Navarino, Chile. Es un hyperoceanic because winter and summer temperatures are not very different. Boreal oceanic in Iceland. You see here the difference, winter, summer are higher. Subcontinental in Finland, higher differences in temperature. Boreal, continental, very high differences this is in Mongolia. And the boreal hypercontinental bioclimate from Verkhoyansk, in Yakutskaya, the difference winter temperatures are very, very low. Summer temperatures rather high. The continental index that measures this difference is 62. Verkhoyansk is the most continental place in the earth. Very extreme, much more than Kazakhstan. And now another boreal seric from Yukon. And let us see some polar, this is polar hyperoceanic. The differences in temperatures among the months are slow, and the temperature is very, very low, really. The median year temperature is minus 0.13. Another polar, here we have some more difference summer, winter, oceanic, polar continental, very high differences in Canada. We have already mentioned polar seric, rather dry and very continental. And the polar pergolide, no 1 month temperature, median temperature is higher than null. So in these places, for instance, McMurdo Station in Antarctica, Terra, there is no 1 month with a small temperature higher than null. Let us see, after seeing the usefulness of these classifications for knowing the stations, let us see some examples of bioclimatic maps. First of all, from these publication we are commenting, you have here the world bioclimates, Rivas Martinez, Riverside, Penas, and many helpers here. Here you have the tropical. Then you have in yellow and brown Mediterranean, some here. Here is Spain, here is Kazakhstan, and it goes into China, and in the south of Australia, in the south of Africa also, the Mediterranean. Here you have the different colors, but you can go look for these rivers, this publication, and you may have in your computer the publication. Then the temperate in green, here, a little bit here, some here, and in North America. The boreal macrobioclimates with its different bioclimates, in blue, and then the polar macrobioclimates in gray here. They produce also a map of the thermotypes of the world. You have here the scale of the thermotypes, and as always in this rose color, the thermotypes for tropical, in brown, the Mediterranean thermotypes, green, temperate thermotypes, a little bit here, and then boreal in blue, thermotypes, and polar. And ombrotypes, about humidity. As you see, here you can see the ombrotypes, and you have green, which are rather humid, in the tropical, near the equator, but also you have very, very wet places in the temperate boreal climates. Here it is due because it rains a lot, but up at these latitudes, 30, 40, it is because it is rather cold. So it rains normal, but the temperature is rather cold, and so the climate is humid. Also here in China, in Western Europe, Central Europe. And then the dry, this brown are already semi-arid, dry, semi-arid, and this red is ultra hyper-arid. You see, in the Sahara Desert, some parts of Arabia, some places in China, it is very, very, very dry, ultra hyper-arid. Now I'm going to show you a bioclimatic study of Peninsular and Balear Spain. This is Peninsular Spain, this is Balear. This study was done with historical data, and it was the doctoral thesis, the PhD thesis of Piñas. So, these are our macro bioclimates: Mediterranean, most of the peninsula and all of Baleares, and temperate. Here, the Mediterranean is divided, you see, in several: Mediterranean pluvisizonal, Mediterranean oceanic, Mediterranean pluvisizonal continental, Mediterranean sedic, Mediterranean sedic continental, Mediterranean desertic, a little bit on the coasts, and then temperate hyperoceanic, temperate oceanic, temperate continental here, and temperate sedic, very small amounts. Here you have the thermicity levels in Spain. The Mediterranean, this is very hot, rather hot, extremely hot. And about the thermotypes in the temperate, thermotemperate, mesotemperate, supratemperate, and in the high mountains, oro and cliorotemperate. And then the humidity in Spain. Arid, desertic, in very small places, semi-arid in the southeast and here in the Ebro Valley, dry most of this brown, most of the Spain, subhumid, a little up in the mountains, humid, this green, and hyper-humid and ultra-hyper-humid in the mountains. It's in the center, also in the center, in the north, and in the Pyrenees. If you put together a bioclimatic level of thermotype and a level of humidity, you have the isobioclimatics, the isobioclimates of Spain. And you see them here. It is a rather complicated map. It is the sum up of all the previous maps, and the scale, the legend is here. Isobioclimates. You see different colors, different drawings. We have in Spain 72 different bioclimates that I have shown you. Moreover, some other bioclimatic maps. This one from Kazakhstan with historic data. We have here Mediterranean desertic, Mediterranean sedic, Mediterranean pluviseasonal, temperate oceanic, temperate continental, also here, and temperate sedic. Here it is not very distinguishable. It's also a little bit of boreal. Some macrobioclimates of Russian Far East. Here we have the temperate near Vladivostok. Almost all of the surface is boreal and polar in blue. And here we have from the same region the ombrotypes, the levels of humidity. This is dry in red, in yellow subhumid, light green humid, and dark green hyperhumid. A bioclimatic map of Australia. Here we have the colors. Till here, this is tropical, this is Mediterranean, and this is, you see here, temperate, and the macrobioclimates. We also produced these thermoclimes, climatic belts. And so you have here the infratropical, the thermotropical, the mesotropical. You have here the infra-Mediterranean, here the thermo-Mediterranean and the meso-Mediterranean, and in green the temperate thermotypes. And finally, I would like to show you a study of climatic change in Kazakhstan. The data are from the PRECIS prediction. With this method, I'm going to show you, you can evaluate, you can quantify and locate the climatic change. For instance, macrobioclimates in Kazakhstan, according to PRECIS for 1980 until 2004, 2010 until 2034, and the third period is 2035 to 2059. In brown, Mediterranean, in green, temperate, and very small spaces, boreal. You see here that from one period to the other, there are changes. This green is less here, has disappeared here. Down, you have here colored all the space that doesn't change during this period. It is 90% of the territory doesn't change its macrobioclimate. And here you see the percentage and the situation of the changes. The next slide, it is the same, but about bioclimates. In Kazakhstan, we have 3, 6, and 10 bioclimates. And you have here the sequence, how it changes. For instance, this green is almost disappearing, at the end disappears. And you see here the territory that maintains its bioclimate and the territory that changes. 33 of the territory doesn't change during the study period with this precise projection. The next slide is about thermotypes, also the sequence. You can see here this brown, this is Meso-Mediterranean. You see here how it grows, So 50% of the territory doesn't change, 49% of the territory changes. And about umbrotypes, you see here the sequence. The colors indicate the classification. For example, for instance, this yellow is ARI, this brown is SAL, this dark brown, this dark brown is dry, second, dry. And about umbrotypes, in this period, from 1980 to 2059, 71% of the territory doesn't change its umbrotypes, and 28% changes. You know the amount of change and where the changes are located. We have also produced maps of isobioclimates. There were 43 bioclimates, but we have only represented 11 of them. And so when you put together all the changes, you can see that 36% of the territory of Kazakhstan doesn't change its isobioclimates, and 64 changes. So with this, I finish. I offer you a link, 2 links of the authors for further questions, possible future contacts, possible master thesis, PhD thesis on bioclimatology, for possible publications on bioclimatology in your country or region, for possible studies of climatic change in your country or region. I have finished.
Yes.
With this, I have.
Thank you, Professor Maria-Luisa. I would like to thank for this presentation. This was so interesting. Dear listener, if you have some question, you can ask them or wishes.
Yes.
Уважаемые слушатели, здравствуйте. Если у вас есть какие-либо вопросы лектору, вы можете задать их. Okay.
I put one in the chat box.
Hello, Michelle.
Hello,
Listen to you.
Maria-Luisa. Yes, Prasil, what your predictions for Kazakhstan, what scenario of climate change did you use? What did you use one of the IPCC scenarios, or what kind of temperature and precipitation change?
The data we are using still are from PRECIS.
Yeah, but what do you know? Can you know what scenario that is? Is it based on the IPCC?
I'm sorry, I have worked the bioclimatology, but the data are provided from Kazakhstan. I didn't check this.
Okay.
I don't understand very much about these predictions. I can use the data, but people from Kazakhstan.
Yeah, but they're, okay.
Yes,
Um,
I should look at the paper.
yeah, because nobody knows the exact set of climate changes that there will be. So did you only do one set of predictions?
Yes, I did only one.
Okay, so,
They had checked the people.
but they're, okay.
Yes, people from Kazakhstan had already tried several possibilities, and according to the comparing the predictions from 1980 to now with the real data, this prediction from Precis, I don't remember the specifications, were very plausible. They matched rather well.
Okay, but that doesn't mean they'll match the future. You go off.
Of course, who can?
Okay. Well, no, I mean, that's why that's the IPCC work. I would suggest looking at a number of scenarios, because we don't know which one will be correct. That's my recommendation. Okay, thank you.
Thank you for the idea.
Gracias. Okay. Right.
На этом, в принципе, мы можем закончить. Спасибо большое. Мы хотели бы сказать лектору нашему и уважаемым слушателям. Надеюсь, вам эта презентация очень понравилась. Maria Luisa, dear professor, I wish like all was good to you. Thank you so much for this interesting presentation. Bye. We can finish.
It was an honor and a pleasure.
Okay.
It was an honor and a pleasure. Thank you.
Okay.
Bye.
Getting off.
There's more news about how to save the MLBs.